Okay, let's talk about logarithms. This is the second section of chapter 5. So you should learn how to recognize logarithmic functions with a common base. You should be able to graph these functions. You should be able to recognize, evaluate, and graph natural log functions as well. And hopefully we can use these functions to model and solve some problems. Okay, so first of all, a logarithmic function looks like this: y equals log base a of x. We're going to read this as log base a of x, just like this says. It's called a logarithmic function, and the base here is going to be subscript, like that. All right, so let's take a look at what these mean. The equations y equals log base a of x and the equation x equals a to the y power are equivalent. Okay, they're the same exact expression. So pause it, take a second to process this. But basically, these equations are the same. So we're going to take equations like this, like 5 to the third equals 125. We're going to rewrite it as log base 5 of 125 equals 3. I like to do this. I like to say that this is the base. So I call this the base. Call this the exponent, and call this the argument, just to give them names. So some, many books will call these things here. So then you can rewrite this in log form as log. You go to put the base down here. The argument goes here, so it'd be 125, and then equals the exponent, which in this case is 3. So what a logarithm is an exponent. That's all a logarithm is. It seems complicated, it seems confusing, but don't make it simple. A logarithm, all it is it's an answer to an exponent problem. So if you have a problem like, for example, 5 to the x equals 125. So say I don't know that it's 3. I don't know. I'm saying what would I raise 5 to get 125? Well, what I could do is write it in log form. I could say log base 5 of 125 equals x. So if I change it to log form, now this is a stored value in my calculator. If I do log base 5 of 125, I get an answer. And that answer is going to be 3. So what a log is, it's an answer to an exponent. That's all it is. It's real simple. It's just an answer to an exponent. Let's try some examples then. This says f of x equals log base 2 of x, where x is 32. So all it wants us to do is do log base 2 of 32. Now, we can do this in the calculator if you have the new software. The calculator will do it. If you have the old software, I'll show you how to use the change of base soon to evaluate this problem. So log base 2, if you go to math, go to number. I'm sorry, just under math. Just under math, if you scroll down to the bottom, it says log base. If you hit that, it'll allow you to fill in the base, which is base 2, in this case of 32, and it'll give us the answer for that, 5. I'll show you how to do this by hand as well. But what this is answering is it's answering this question: what exponent do you raise 2 to get 32? That's what this means. Log base 2 of 32 means what exponent would you raise 2 to get 32? And the answer to that is 5. Okay. So the rest of these, real quick, you can just enter them in. Log base 3 of 1 for part B. You can evaluate that in your calculator. In your math, scroll to the bottom, log base. Base 3 of 1 gives you 0. So basically, what would you raise 3 to get 1? Well, the answer is 0. So x equals 0 for that one. X was 5 in this one. I'm sorry, I should say f of 32 gives you 5, because these are functions. So for this one, f of 1, if you stick in 1 here, you get 0. Okay? You stick in 2 into this function, f of 2 is equal to the log base 4 of 2, which is equal to, and if you're not sure, you can rewrite this, that's 4 to the x power equals 2. The answer to that is the square root, or x equals 1/2. So that's going to give you 1/2. You can check that in the calculator again. In fact, a shortcut to do it is to do alpha window. Under alpha window, you can click 5, which is log base. It's a little bit of a shortcut. Log base 4 of 2. Whoops, not graph. Sorry about that. Gives you 0.5, or 1/2, just like we thought. So that's 1/2. Part D then, f of 1 over 100, in this case, is equal to log base 10 of 1 over 100. I'll show you how to do this by hand later, but basically just enter that into the calculator for now. That gives us, do alpha window, oops, alpha window 5, log base 10 of 1 over 100, let's enter in a fraction here. Gives you, I'm sorry, not graph, just hit enter. Gives you -2. Okay, so we've got the answers to all these. A, B, C, and D. All right, some properties of logarithms then. Obviously, any number to the 0th power gives you 1. So that would mean that log base that number of 1 is always going to be 0. If you just change it from exponential into log form. Same thing here, that a to the 1st power is just a, so that means log base a of a is 1. And any number raised to a log base of x is just x. So you can also rewrite that like this, log base a of a to the x is just x. So these a's tend to cancel. It will basically just, if you rewrite this expression right here, you'll get a to the x equals a to the x. Okay, same thing here. If this is true, that x must be equal to y, because you can do this. You can do base to the exponent equals the argument. Well, we know that a number raised to the log base of that number cancels, so it's just y equals x. Okay, that's using this property here, inner property 3 as well. Okay. Okay, so we could sketch the graph of each of these functions. Y equals 2 to the x looks like this. We already know that from the previous section. It goes through the point 0, 1. Okay, now this function g of x, log base 2 of x, is the inverse of this function. Because if I rewrite this function, if I switch x and y, so I'd make this x equals 2y, and then put it from exponential form into log form, that'd be log base 2 of x equals y, which is what this function is. So all I did was switch x and y from this, I called this y. Okay, then I switched x and y, solved for y, and got this. Well, now instead of calling it y, I'll call it g of x. Okay, so you can see that these are inverses of each other. So inverses, we know, are reflected over the line y equals x. So that function looks like this. It's obviously going to go through the point 1, 0. Inverses, they switch x and y. That's what inverses do. Take all the x values and all the y values and switch them. So we can sketch this graph pretty easily. In fact, I'm sorry, I didn't draw this very well. It's going to have an asymptote of the y-axis, so it's like this. But it is the reflected image of the exponential function y equals 2x. It's always going to go through the point 1, 0. The base will change the general shape of it, but it'll always go through this point. It'll always have an asymptote of the y-axis. So the domain will always be, the domain and range are switched between exponential functions. The domain of an exponential function is always negative infinity to infinity, right? Because an exponential function looks like this. You have any x value for a domain. The range is always going to be 0 to positive infinity. As you can see how these two are switched because they're inverses. The x-intercepts at 1, 0, like we said, it's always increasing. It's 1 to 1, and therefore it does have an inverse function, which is the exponential function. Okay, so obviously the same thing holds true then if we do log base e of x. We're going to call that the natural log of x function whenever there's a base e. But its inverse is, if this is my function f of x equals natural log, its inverse is y equals e to the x. Because if you change this to an exponential, you'll have, this is the base e. You don't write it in natural log, but e to the y, so e to the exponent, which would be, I'll call it y instead of f of x, equals x. Well, now I switch x and y to find the inverse, and you get y equals e to the x. So these are inverses of each other. This exponential function y equals e to the x, and the y equals natural log of x. Okay. You can see that they're graphed here. Here's e to the x, here's natural log of x. You can see they're reflective of the line y equals x. So they are inverses of each other. Okay, let's use a calculator real quick to determine the natural log of, say, 2. All you gotta do is plug this into your calculator. Just grab your calculator, and natural log button's right here. So natural log of 2 equals decimal. You can round that, but you can see how you can plug all these in. Okay, that's not a problem. All right, some more properties of logarithms. And the natural log of 1 is 0, and here's the exponential version of that. If you do base to the exponent equals the argument, you get this. Obviously, anything to the 0th power is 1. So natural log of e is 1, and that's if you look at the exponential version, base to the exponent equals the argument, you get this equation. So obviously, e to the first is just e. And the same thing with these. Base to the exponent gives you this, and you know, e to anything just gives you x. E to the natural log, those cancel. Okay, and the last property, natural log of x equals the natural log of y. That's a one-to-one correspondence where if you go e, you change it to an exponential, e to the natural log of y equals x, well then obviously these cancel and you get y equals x. Alright, so let's look at an application problem then. This function right here is the human memory function, which basically, you know, some researchers got together and had some subjects take a test, and they tested their memory of that content, you know, every month, and modeled that data with the function. Here's the function. So if you look at that in the calculator, you can see that over time, the memory decreases slowly. Eventually, it does go down to 0, eventually way out to the right. So eventually you will forget everything if you don't relearn it or keep it current. But so this is the function that models that memory. We can answer some questions about it then, like what was the average score on the original exam? It tells you that's t equals 0. So if you plug in t equals 0 here, then you'd have, you know, just 75 minus 6 natural log of 1. Natural log of 1, if you want to know what that is, we can rewrite it. Say you don't know what it is, write base to the exponent, so e to the x equals 1. Well, obviously that's 0, right? Because e to what power gives you 1? Well, that'd be 0. So this is 0. So the average score initially is 75. Okay, so originally the C was the average of the test. Okay, but over time, obviously the score will go down of how much you remember. So you can imagine after 2 months the score should go down. So let's try that. 75 minus 6 natural log of 2 plus 1, which is 3. Now you can evaluate this with your calculator real quick. That's easy. Or you can just grab your calculator, and since I have the function plugged in for my y equals, what I can do is go to second table, table set, and I'll start my table at like whatever 2, and I'll go by increments of 1, and I'll just look at the table and get these values. So you can see after at t equals 2, 2 months, the average score was 68.5-ish. Okay, and then at 6 months, you can look back at the calculator. Again, at 6 months, the average score was 63.3 about. So you can see how the score is decreasing as time goes on, which is what you'd expect. Okay, well this helps, and we'll make a homework out video on this same stuff.